Hey guys, Cloud here, and today I will be showing you how to use the depth buffer for shaders. So as I've said before, shaders are a pretty complicated area. You can't just make one video on them and expect it to cover everything, or expect it to be under an hour long. So today we're going to be covering the linear depth and exactly how I did this flashlight shader. I'll do a little hand waving when we get to the flashlight part. I'll explain each of the core pieces, but some of it you might not be able to intuit yourself why it works that way, because it requires some math, but at the very least we'll get to how the flashlight shader works. So this is just going to be for constant. We're not going to be able to toggle the flashlight on and off. That is going to take its own video, and I'm still personally, I don't have a method that is foolproof enough for me to be comfortable sharing it with you guys. So I'm not quite ready for that. Maybe I'll be ready in a little bit. So as you can see, the blocks that are closer to me, the closer I get to them, the more they become illuminated to a certain extent. But then the further they get, the less illuminated they are. And to give you guys some compare and contrast, let me show you what it looks like without the shader on. So a lot darker. You probably barely can see stuff. So that is the depth shader. We're going to be going over all the code required from the ground up, how to make something that utilizes the depth buffer, which is really the revolutionary feature of 1.16. I believe it was added in 14 or 15 or 16, one of those three. But it's really revolutionized shaders and what we can do with them. So we're going to need a new resource pack. I will call this depth tutorial. Enter. Okay, inside it you're going to need some default folder stuff. So let's go ahead and hop into versions 1.16 and open up our jar with a WinArchiver. A WinRAR is the best method to open the jar in my opinion, but other people have their favorites, whatever, who cares. All right, so we go to the depth tutorial and we're going to want a folder. We're going to want something that follows the path of a resource pack normally. So you need assets pack, pack.png is optional. So I'm just copying it from another one, but it's pack.mcmeta. I would assume that if you're in this video, you know how resource packs work. So you do assets, then you do Minecraft, and then you just go follow the same path. So you go shaders. And this is going to be using the transparency shader, but the depth buffer can be used on some other shaders as well. But the transparency is typically the best for like a constant shader. So then you need post and program. So we have post, which is going to be, as I've discussed in a previous tutorial, I'll link all my other tutorials in the description. This will probably be in a playlist anyways. But post and program, post is what posts it to your screen. Like, for example, post is going to be what method it originally uses, and then it kind of like tells you the direction. So use this shader, then that one, then that one, then that one. And then program is what the shaders that you tell it to use are actually doing. So post is just going to be our transparency.json. So we'll copy that over and then open this guy up. And then we're going to have program. And program, we're going to probably want just, we can copy some the blit, which is the default, and we can just copy that. Okay, yeah, that's good. Okay, so, and then we'll rename it to depths and depths, just like that. You can also use subfolders in here too for organization. I'm just not going to use it in this video. So that's really all we need. Now the next part is going to be the magic word part. So well, not really, we can find it here. So in the transparency shader, you'll see what it does. So it does the transparency program. It runs it on main, which is the thing that the game initially posts to your screen. So main is just going to be kind of like everything, all the pixels the player sees at one particular point in time, with no added effects to them, such as entities that are glowing and whatnot. No special effects, just kind of a raw picture. And you can see what that is by how that actually, what it actually is evaluating by just kind of cutting this guy out and just making main go straight to final. Final is usually what it's going to post to your screen when you're all done. So we take main and then we post to final. and we run the transparency on main, and then the output is final. And then these are our additional targets. And then after we do that, we run blit. Blit copies final back to main. So then once this is just something that we add pretty much to the bottom of every file. Just copy final back to main, because in the end of the day, main is what's going to be drawn to the screen. So main is kind of like your input, but it's also your output, but you can't do it all in one step. So you split it into two. So you can't just go from main to main. You have to put it on a intermediate kind of variable here. So what we actually want is two things here, but really just one. We want the diffuse depth sampler right here. So we can really just copy this whole thing if you want. Enter, just like that. Change this guy to depths to run our depths guy. Change this to final. And let's just go to like trans and then to final. And then instead we write to trans, which is just like a transform or whatever. And then we add our new variable here called trans. And I've gone over in detail what all these things are in another video. So you should check that out if you're kind of confused on this step. I just need to save time for this video. Anyways, so here we have the depths, and it writes from trans to final. So this is after processing the transparency buffer. And then we're going to use the diffuse depth sampler as an additional kind of guy that we're passing, like information, a new buffer that tells us stuff. So we go to program, and now we have depths and depths.json. So depths.json, we need to add a new sampler here, and the new sampler is going to be our diffuse depth sampler, just like that, just so it knows what you're doing. So here's your diffuse depth sampler. Okay, so I copied some stuff from my other version just because I don't want to break anything, but instead we make blend do 1 and 0 here. So I guess we're adding 1 and 0. I haven't really messed with blend too much myself. Then uniforms, I added a few. There was projmat and color modulate. We don't need color modulate. We do want one called screen size, and all these is you can just copy the words here. They're pretty much all the same. And then FOV is your field of view, and that is a float, and we're setting it to 70. So these are just a bunch of variables that we're passing in, or uniforms. So inside this file, I'm just going to update the version to 130. That's what I prefer to use. Then we also need to create a new line for the diffuse depth sampler. So this means we have a uniform that is a 2D sampler. And then we have text chord, and then we have to initialize the other uniforms. So I dragged those uniforms in here. So these are kind of their things. So you have a mat4, you have a vec2, that's just two variables on a vector, and a float. And then what the blit does is it takes the diffuse sampler, and we don't have color modulate. It takes the diffuse sampler at the text chord, grabs the 2D texture, evaluates it as a 2D texture, and grabs the pixel colors in alpha, and it puts it to the frag color. So in main, we're constantly writing this frag color for every pixel on the screen, and the diffuse sampler, we access it at the text chord. The text chord is constantly changing every iteration of main, and it lets us grab different pixels. So we also need to do this with the depth, but the problem is depth is not linear in Minecraft. And what depth is, because maybe I did not explain this too well yet, but what depth does is each pixel is assigned a numeric value for depth in game. So what that means is when I look at this chest, it's going to have all the pixels with the chest are going to have a higher depth value that'll be really basically the same. It'll be higher depth than this fence, which is closer to me, but it'll be lower depth value than that wall, which is behind it. So this is perfect. So let's just access kind of distances of things in the game, which will let us do make something brighter when it's closer and darker when it's further. So part of the magic that Oh Nowhere made is, I think Oh Nowhere, it was either Oh Nowhere or Sabene or both of them. don't know if I'm getting this accreditation right, but they made this function called linearized depth, which is just based off of the wiki, which essentially like turns depth into a linear variable. So 1 unit of this depth is equal to 1 unit of depth in the game. I'm not sure exactly whether a 1 means 1 block or a 2 means 1 block, but at least we know that if we change a value, we can expect it to have a linear scale effect. So this will turn depth into some linear value. Now what we can do is we can do logic based on depth and grab values based on depth. So what we do is we go to the depth sampler, right? It's basically a 2D array of all of the pixels on your screen. We go to the coordinate that we're currently at, and we grab its value. Then we grab the R value because depth only has one number, so we just go .r. Texture 2D will return an RGBA value. So we just grab the R, and then this value will be some number that's a float, and we'll pass it to linearized depth, and linearized depth will output a float, and that will be our linearized depth value. So now what we can do is we can take this texture, right? And we can go texture, we can create an intermediate variable if we want. We can go vec4 color equals, and we can grab this number. So this will give us an RGB4 variable, vec4, that's RGBA. And we can do vec4 of color.rgb times depth and color.a. So that way we just maintain the alpha in the RGB. Okay, so important thing is to make sure that it's telling it to use the right fragment shader, which is this guy. Otherwise, you're just going to make it use blit, and you'll just have a black screen. So here is a fog depth shader, a linear fog. This is just like blindness. So what I did was I did same as I showed before. So we took RGB, the color, we grabbed the color, which is going to be a 4 vector value. We divide the RGB by depth, and we put the alpha on the end, and we put that onto the frag color of what we're actually drawing. And what this is going to do is basically the further something is, the darker it will be, because depth is going to get bigger, and an RGB value divided by something big is close to 0. 0 is black. So this just makes everything linearly darker. So how do we make something kind of, that's pretty much all the tutorial I wanted to cover in terms of how to use the depth buffer, where to put it, and some application of it. But now I'm going to cover like the flashlight aspect. So we're going to do some basics here. It's going to be like, how do we draw a circle? So you have to draw a circle in a very weird way. So the coordinate that you're at, that you're drawing, you have to use kind of conditionals in the sense of we have to be able to say for any point, what should its value be based on some function. So we need to design a function that would output a circle. And what function outputs a circle? You could do the circle. So x squared plus y squared equals r squared. So I just pasted it in here, and I will have this chunk in the description. Well, no, I will have this whole resource pack in the description. So what this does is this grabs distance, which is going to be kind of like the distance from the corners of your screen based on your FOV. This is a complicated thing that little function, not really too complicated, but it's a little function that Disco Hound sent me, I believe. And then we take the UV, which is going to be, this is where the actual circle happens. That is kind of like a separate thing that is used for the circle, but in a different way. But this is how we actually generate the circle. So we take the text coords, and then we get the x coordinate minus 0.5 puts you at the center of the screen. Pow, so you square it, and then you square root it, square root the whole thing. So this is just x squared plus y squared square rooted, but then we shift it to the center of the screen because x and y is going to be based off of the corner of the screen. So this gives you d, which is going to be kind of like where you are in the circle. So then you adjust d to give you some, so normally it would just be some value that is based off of where you are in the circle, but instead we have to adjust it so that it is actually kind of like the amount that you're supposed to expose based off of how close you are to the center. So we take d, or what it was here, so where you are in the circle, times AOE, so this would make the circle bigger or smaller based off of some variable, and then we do the exponential, so this will fade the circle, and we do it of a negative exponential. So it decreases instead of increasing. So we decrease as we go away from the circle of a specified size with a variable. And then we take that reduce thing that is constantly getting smaller the further away we get, we multiply it by exposure. So this will kind of affect how the curve dampens, how quickly it dampens. And then we divide the whole thing by distance times 0.15, and 0.15 is just something I have adjusted that you can change. And distance is going to be this value here. So then if we have some variables for flow, for exposure and AOE, which you can change, then this will give us some value between 0 and 1, or some value that corresponds to how much we should expose the pixel based off of how close it is to the center of the screen, and how far away it is. So this actually takes into account the depth in here. So we're just this distance transforms the depth based off of your FOV. So then inside the final line, you have the frag color. So what do we do with the color? So in the color, we grab the color's RGB, we multiply it by a value that is clamped so that it doesn't get above like what it should be. And we clamp it between 0.1 and 10. So it'll either be 10 times brighter or 0.1 times brighter. It won't be any bigger than that. And the value that we calculate is 1 plus D. And then so that will just be whatever D is. So we have 1, which is going to be itself, right? So it'll be just no color, plus D makes it increase color based off of how close it is to the center. And then this value will be between 0.1 and 10. Really, we could say between 1 and 10 because the D shouldn't be negative. And then finally, we just give 1.0 for the alpha. So if we do all that, we end up with a flashlight. And how you do the flashlight can differ. I have different methods and different implementations. Really what I mainly change is this section here. So 1 plus D, you can also do other math inside here to make it everything around you is darker just by default, and then the D just makes things brighter in the center. That's what I have for my kind of other project that I've shown before in my previous. But in this case, I'm just making the flashlight not make anything darker around it. So it just makes things brighter. And you can see, yeah, that definitely makes things brighter, right? And maybe this is too powerful and you think this is too strong. Well, you can just change the exposure to 2, hit F3T. And now that's a little bit less bright. And maybe you want the radius to be really big. So let's go 15 and let's change the exposure to, yeah, let's leave it 2. So if we change it 15, then our circle is going to be really big. It's going to be changed. It's not going to necessarily be huge. But we can just tweak these values till it looks exactly how we want it, the AOE and the exposure. So that's pretty much all I wanted to show you guys today. This is kind of just a copy paste because I don't want to go through every single bit of code associated with it. Hopefully this was useful to you guys. Next time I'm going to try to put together some kind of a shader selector next time I do a shader video. But it is definitely buggy right now, so I don't want to show it off until I've kind of polished it more. Other than that, thanks for watching, and I'll see you in the next one. Peace.